A lot of the time in development programs like this, the days are long and hard and you're just battling, trying to solve one problem after another, after another, after another. Today hasn't been one of those days. Today has been a really, really good day. So you've been following us over the course of the last 2 weeks, really, doing quite extensive work, setting up GT50's combustion system so that we can be confident that when we run the engine for the first time, we don't damage any of the valuable prototype hardware. So the first time we introduced this to you, it was really about getting the combustion system lit. Can we get fuel in at the right pressure? Can we atomize satisfactorily? Is the igniter in the right place? Can we get the flame to light? And then can we hold it stably at that point? We did that a couple of weeks ago. Tick, done. That part of it works. The next thing that we have to do then is to start to drive the combustor through an initial ramp up through the starter cycle, up to the point where it approaches ground idle. And so the next phase of work was managing the fuel-air ratios as we drive the combustion system through higher and higher and higher mass flows, higher pressures, and making sure that the swirler arrangement that we use to constrain the flame and then the primary holes and the dilution holes are all functioning properly to set up the stable recirculations at the back of the combustion zone to make sure that we can ramp up and down through a wide range of fuel-air ratios effectively and in a controlled way. During that process, we had to deal with a couple of issues with the swirler, so getting those to be optimally set up for our configuration. And we also had to deal with some pulsations, some interactions between the fuel system and the combustion aerodynamics and thermodynamics. All of that's been resolved. Tick, done. The next thing that we had to do was then drive the combustor harder and harder and harder to make sure that we can operate stably, initially up to ground idle, and then we've got to push it to flight idle, and then we're into testing on the engine platform. But of course, the problem in doing this is very quickly the amount of air power that you need becomes utterly enormous. So if you look under the bench here, what you can see is that we've essentially got two heavy duty blowers that have been providing the air here, but these literally can only get us just past the airflow that you need for ignition. Remember that at max power, GT50's compressor consumes over 1,000 horsepower. So the equipment that you need to be able to exercise the system up to those higher power points becomes really complex. Not only have you got to have a supply of compressed air, you've also got to have that air at the right temperature to get the density conditions just right in the combustion chamber to be able to simulate what will happen in the engine properly and get the controls and get the combustion physics and the control system set up just right. So over the course of last week, we reported the findings that we'd got the fuel nozzle set up properly, we'd got those under good control, we'd got stable operating just past ignition, and then the next challenge was to essentially push this up to ground idle. But these old girls are nowhere near strong enough for that. So how do you go about getting enough compressed air to drive this thing as hard as a gas turbine engine would do it? Simple. You get a gas turbine engine. So come and have a look at this. The way we've done this is we've essentially got an air starter unit from another aircraft. And essentially this is about a 250, 300 horsepower gas turbine engine with a double entry compressor system here that's designed to produce far more air than it actually needs. And they use these to start old civil airliners, they use these to start military aeroplanes, and essentially they connect up to the compressor outlet here with a big flexible hose and then drive large quantities of compressed air in a very compact unit into whatever you want, whether it's starting somebody else's gas turbine or running our combustor test rig. So what we've been doing today is essentially getting all of this hardware connected up to the GT50 combustion system and then driving the combustion system up to much higher powers, much higher airflows, much higher fuel flows, and making sure that the system remains robust, that we're getting great combustion efficiency, that all of the things that are supposed to happen in the combustor work when we can still see everything. You can't fix these problems inside the engine, and we need to know that we've got a control of the combustor delivery temperature, that we're free from pulsations, that we know exactly how to map the fuel as the compressor delivery air goes up and up and up. And so that's what we've been doing today. So just behind me outside the factory here, we've had this engine driving compressed air into the compressor delivery rig. We've then been able to meter the air very carefully going into the engine, and then run the engine through a succession of higher and higher and higher air fuel ratios. And while we've been doing that, we've now got a solid blue cone, so we can push all the way to a nice efficient and then a lean flame, push the system all the way through to the lean extinction limit, and get the system working just right. So I can now say that all the way up to and just beyond actually the ground idle point for the engine, which is the first checkpoint for the testing program, that the combustion system works just right. So over the next couple of days, we're going to focus on automation. So we're going to take our fuel control system, use the combustor rig to take all of the learnings and put those mappings into the fuel control system, so that we can automatically spool up and spool down the engine to hit all of the test points that we need to. So it's been a really, really successful afternoon here at PC1. Your combustion system's working, your fuel delivery system's working. We're ready to run the GT50 engine through its first few tentative stages of its test program from both a fuel and a combustion physics point of view. We'll get that coded up and tested tomorrow, and then we're ready to start implementing that on the prototype engine itself. Let's go and have a look at how the prototype build's going. You know, on so many levels, today has been a fantastic day. It's kind of made me reflect a little bit at how far we've come in how efficient we've become at generating the engineering outcomes and the engineering problem solving that we need to get all the elements of HX50 and GT50 together. Gone are the days when we used to design overly elaborate test rigs and control systems and make life trying to be perfect too early. And what we've done today is a perfect example of how to do the least to get the most. We've got a third-party gas turbine engine. We've connected an air starter system to our combustion system. We've wrapped a simple control system around it. And then we've executed a program of testing that's given us exactly the engineering outcomes that we wanted. And we've gone from zero to hero in just a few hours. It's been an incredible day. And it really gives me such a lot of confidence for the test program that we've got ahead of us now to march GT50 through all of the different stages of testing and development that it needs to be flight ready. And it's been a lot of fun as well. I mean, when that turbine engine fired up to drive the compressed air, it was a complete din of noise, and we got huge amounts of heat and energy under careful control by our team. When the hose first inflated, it goes rigid and I jumped out of my skin. But we've managed to control all of the airflows and get that combustion system working just right. Come and have a look at this engine. So welcome to the mechanical assembly lab. This is the lab we've featured a couple of times before, building the MGU and then building the speed reduction gearbox for the GT50, and now building the prototype GT50. So we've explained on a couple of these updates that this first build is a very slow and very methodical process, because there's so many critical parts in here. By critical, I mean parts that took a long time to make, that have to be set up just right with just the right clearances to function properly and not damage themselves. So the nature of the build process, if we take a look here, the engine is built nose down. So this is the inlet casing. And then on top of the inlet casing, we first fit the spring bar and the squeeze film damper, and then the forward gas generator bearing, the forward gas generator shaft. And then on top of that, we can then locate the inlet shroud. This is the shroud that controls the precision tolerances between the blade tips and the stationary frame of the engine. Getting those tip clearances just right is the difference between having the compressor work stably and to be performant and not. And so we've had this together and apart and together and apart and together and apart, just getting that set up just right. Every part on here has had a full CMM geometric survey so we know what we've got, but then getting the parts to interact correctly is also really important. In production, this will be a much quicker process, but right now we're aiming to get all of the components set up just right, all at nominal tolerances, so we know we've got wiggle room in both directions to get those clearances just right. So the compressor's been set up, and you can see here we've got a precision shim in between these two faces here, and when we build the engine we've got a range of different standard size shims, and we control the tip clearance of the impeller and then the outlet clearance and the clearance to the diffuser with an additional shim in here. And so we have to get all of these components, the flanges and all of that sort of stuff set up just right to be able to get the engine to go together. So over the course of the last couple of weeks, the final build of the rotor, including the final impeller, the final disc, the final turbine blades, all the new spring clips, have been off and been balanced to really, really tight dynamic tolerances. It's come back here, we've then broken it down, and now we're building the engine around that rotor. So the shims have gone in. As we've been building the engine, all of the pigtails for the instrumentation are in there. So it's full of pressure sensors, it's full of thermocouples, it's full of accelerometers and a whole variety of other sensors that we need to be able to understand what's going on inside the engine as we test every little nook and cranny of its operational envelope. So what you can see here, the inlet casing's in, we've now got the intermediate casing, the shroud's in there, it's all shimmed up properly. We've then got the vane diffuser, so this receives the air from the compressor and then turns it and sends it down the sides of the combustor casing. We've then got the front face of the combustor liner in there, so the liner is built into the engine. And then as we come backwards here, we've got the nozzle guide vane, so these are our cast nozzle guide vanes that have been set up, fully machined, and have all of their seal faces on them. And then the heart of the beast, we've got the HP disc. So this is your gas generator turbine disc, gas generator turbine blades, all the spring clips in there. And then from there we can put in the blade shroud. So this is the component that the blade tips run in. It slides over the top with its protective abradable lining in there. That goes over the top of the disc. And then we can put the rest of the combustor liner on the back of it. The combustion casing goes over the top of that, the interduct and the bearing housing on top of that, and that then is the full completed gas generator section, ready for its nozzles and ready for the initial testing. So there's a few more strips and rebuilds to do to get these back components set up properly, but it's going together beautifully. And the current schedule for this is we do expect to have all of this engine together now by the weekend, or say Monday at the absolute latest. So next step, once we've got that built, is to get it on the test rig, and then we can make a start.